What's going on, folks? Is the audio coming through all right? How's it going with you? Can you hear me? Can you hear my voice? Can you hear the words that are coming out of my mouth? It's scratchy? Alright, I apologize. I'm sorry that it is scratchy. I bet you that it's because my computer is overheating and I don't know how to stop it because I think I need a new computer. Alright, the second question is, can you hear my, can you see my face? Can you see the video camera? Okay. Wait 1 second. How's about now? Is it better now? Okay, awesome. Awesome. Then why don't we do this? Alright. I know I assigned section 5 for you, and I feel like that might have been a mistake. So what I'm going to do is I'm going to unassign it. I'm going to just give you guys, or you know what I'll do is I'll even do better than that. I'll give everyone full credit for assignments in section 5 without even doing it. I'll just give you the credit. And I'm going to skip over to section number 6. Say yay, or oh man, or whatever. I don't know. It's up to you. What do you think? Is that all right? What I said is section number 5. I don't feel like I did. No, don't. What I said was for section number 5, I'm going to give you full credit for it without you guys having to do it. I'm going to send out an email today and say skip section number 5. I decided against using that section, but I'm going to give you full credit for it anyway. So you get the points without having to do that. Are you happy? Yay! Awesome. Good. I'm glad you guys are alive. Awesome. You already printed that entire packet. I apologize for wasting your paper. I'm actually going to probably be coming back to that section, but I need to think about it before I assign it much better. Anyway, let's talk about today's section. Full graded for what it's choppy. Oh, I'm not sure what you mean. You need to speak English in this class. I apologize if the audio is choppy. My computer's overheating. I'm going to try to get that fixed as soon as possible. Alright, here's what we got. I have a graph. All I want to do is I want to figure out when this graph is constant, when it's increasing, and when it's decreasing. Let's do this one. Actually, I'm just going to make this one up. It's a different graph. And you know what? I need to grab some colors. Give me a second. Alright. I have a yellow expo marker, but I don't think you'll be able to see yellow. So I'm just going to use blue instead. Alright. Wherever it's constant, where is it constant? Well, it's constant when it horizontal lines like this, right about here. So I'm on package number 6 already. I'm doing that one. When it's increasing, I'm going to do it in blue. That looks like when it's around here. Also when it's around here. That means in general it's going up. I know you can't really see the blue. Is that better? And then where it's decreasing? Well, it's decreasing over here. It's where it's kind of generally tending downwards towards. It's definitely decreasing over here. Are we cool with that? So you guys think you guys can do this first warm-up page by yourselves? It's not that hard. Good, let's skip it. Or not skip it. You guys have to do it. I'm going to skip it. I'll grab some papers. Oh. Okay, this is actually going to be kind of fun. Let's kind of come up with some ideas. Now, I wish I could share the computer screen with you, or you know what I wish I did? Is I wish this were a regular classroom where I could actually have you come in and try a few of these. But let's try doing this. Let's connect point A and point B. And let's try to figure out different ways we can draw this. Now, here's the rules. I need to draw something that connects point A and B. It doesn't have to be a line, a straight line. It could be. It always has to be increasing. So let's use red for that. It always has to increase. Okay? So one of your graphs could look like this. That connects point A and point B, and it's always increasing. All right, Sarah is saying, okay, wait, what about this? What about this? Sarah's saying, okay, so one of your graphs, draw that line. The other one, try this one. I agree with Sarah. That's half of a parabola. See, the parabola looks like this. That would be only the right half of it. Is that what you're thinking, Sarah? Is that what what's going through your head? Yeah, perfect. I like it. So if on another one of those graphs, draw this one. Let's come up with other ones. What's another one we can think of? What about this? You guys agree? Why don't you agree? It's increasing, isn't it? It's always, no, it is. Is there ever a point where it's decreasing? I'd say no, it's always increasing. It's always getting, if you keep going to the right, it will always go higher than when you were at the left. Now, I kind of understand where you're coming from, Sarah. If I can read your mind, let me try. I think that what your problem with this is now is if you're saying, well, wait a second, but what about over here, as you go to the right, you're increasing a lot, right? But over here, as you go to the right, you're only increasing a little bit. If I take one step to the right, I'm shooting up over here, and over here I take one step to the right, and I'm only shooting up a little bit. Yes, but the point is you're still increasing. You're still going up. Maybe you might not be increasing as much as where you were over here, but you're still increasing. Do you agree? All right, now with that in mind, let's draw one more. And I already gave you, what, 4 of the answers to your graph? Let's try this one. Is this an answer? Is this constantly increasing? Sarah says no. It looks like it to me. I mean, if I were like a person, I could just kind of walk up these steps. Why not? What's the problem with this thing? It has lines that aren't increasing. I actually agree with you. I agree with you 100%. Yeah, it has lines that aren't increasing. Actually, here's an even better answer is it's not a function, right? It's not even a function to begin with. Because remember, what did I tell you was the test for whether or not something is a function? Now, Natasha, since you're new, I'm not going to pick on you. I don't want to pick on you, but I just want to make sure that I'm taking into account that where you're coming from. I want you to stop me if you're ever confused. I taught them earlier how to figure out whether something is a function. Now, let's go back and just kind of say, okay, well, is this a function? Yes, okay. Is, actually, you know what, I'll just do it like this. I'll do it in a different color. What about this? Is this a function? The black one. Is that a function? No. No. Natasha, do you know how to tell whether or not why the red one is a function and the black one isn't? I'm not picking on you. I just want to make sure that you know. What we did was we learned this thing called the vertical line test. Now the vertical line test is very simple. All you got to do is take something that's straight and make it a vertical line. And then you kind of use it to scan across this thing. If at any given point, this like laser line that you're scanning crosses at more than one point, for example, right there, see it's crossing at 2 points, then it is not a function. Whereas this red line, no matter how much you scan it across like this, it will only touch the red part, or it will only touch your line, your vertical line, at 1 point. So, this right here, this graph right here, is not a function because, look, right here, it's crossing at much more than 1 point. Or over here, or over here, or over here. Does that make sense? In fact, not only does it not pass the vertical line test, it actually has vertical lines in it. So this isn't a function. You're not allowed to draw these. Alright, that was warm-up. That was still warm-up. We cool? Erasing. Next page. By the way, just so that you know my style, I actually started doing your homework for you in class. I don't do all of it, obviously, but I do some of it. So I think I just did 5 problems for you. Or 5 of those little graphs. You can have as many graphs as you want. Alright, let's see. What does this one say? Match each graph to a particular runner based on the description of each runner's behavior. Write at least 2 sentences to describe how you determine the graph matched the runner's description. Each graph describes the distance that the runner has traveled versus time since they started running or walking. All right. So what are my graphs? Oh, okay. So I've got one graph that looks like this. I've got one graph that looks like this. I've got another graph that looks like this. What did the first graph look like? Look like this. There we go. Okay. We cool? Alright. Jay runs cross country for a high school team. He decides to go for a jog around the park on Thursday afternoon. Luckily for him, there were not many people in the park, so he could run at a comfortable pace for an entire hour. Now, I got a question. Did Jay seem like he sped up? This is supposed to be more straight. Did he seem like he sped up? Or did he seem like he just kind of ran at the same rate? Come on, you guys, talk to me. Talk back. What do we got? He ran at the same rate. So, since he ran at the same rate, which graph do you think this one is? Is it 1, 2, or 3? Which graph represents what J was doing? I agree. That one's J. Because J kind of runs at the same rate. As time increases, his distance increases proportionally. All right, let's try this one. Jessie usually walks to school in the mornings. Today, she decided not to check the time when she left her house. She started walking and realized that she was late and sped up until she started sprinting to get to her class in time. Yes, this is next week's homework. I'm actually doing part of it for you. Yes, I agree. Because at the beginning, she's not that far. But then as she goes on, she realized, hey, wait a second, I'm running late. So she's increasing her rate. So it's getting faster and faster and faster and faster and faster. So this would be Jessie. We cool? Well, by process of elimination, this is June. But let's figure out whether or not this is correct. June decided to run as exercise first day. He started off sprinting around the neighborhood, and he's running really fast. But fatigue kicks in, and he slows down until it becomes a walk, and eventually slows down to a stroll. So he's like, He's like Mr. Daldy. This is Mr. Daldy. Ready? Let's go for a jog. All right, Mr. Daldy. Wait. Right? That's what June did. June was running real fast. He starts off real fast, and then he slows down, and he gets tired, and then he stops, and then he walks, and then he like strolls, and eventually he just lies down on the ground because he's just so tired. That would be me. Cool? That's what I was describing. And I think Sarah's saying what, and because she was trying to hear what I was saying, but I wasn't saying anything. I was just breathing hard. All right. So now what you have to do in your homework is describe why you think these are correct. And you can't just say, because Mr. Dalday showed us the answer. You have to explain what characteristics of these graphs made you think that it goes along with that particular story. Erase. Ooh, this actually looks cool. Fill in the following table. Choose from the 7 verbal descriptions at the bottom of the page. Oh, okay. All right. You know what, Justice? If I canceled Chapter 5, Section 5, then nothing's due today. Sound good? I'm canceling Chapter 5. Nothing is due today. Work on Chapter 6. It's due next week. Welcome to math class. No, I just want to make sure that I want to make sure that I give out really good assignments. And I feel like I didn't when I put that one up, I didn't think about it all the way through. So I'm going to send out an email right after class and say, you know what, you guys, I'm going to cancel that section you need to do. Just work on Chapter 6. All right. So let's see which of these descriptions, I don't know if you can see that really closely, which of these descriptions best match up with this line over here. Actually, you know what, let's do this one. So which of these descriptions best match up with this line right here? Here's the graph. Something like that. So what is it doing? It's when you start, it's going to what? It's doing what? Well, to start, it's actually increasing because it's going up over here. No, to start, it's increasing. See, it's going up. I'm doing the second one, by the way. It's going up like that. And then, after some point, it starts to decrease. So I would say my verbal description of this graph would be increasing at a decreasing rate. And then decreasing at a increasing rate. That's how I would verbally describe this thing. I know you can't see that, so let me actually just put it there. It's increasing at a decreasing rate, and then it's decreasing at an increasing rate. Do you understand what I said and why I said that? Oh, okay, all right. Let me kind of describe this for you. This part describes this arrow right here. When initially, to begin with, and we're going along this parabola or piece of parabola right here, initially to begin with, it's increasing, right? From here to here, it's increasing. It's getting bigger. Do you guys agree? But what it's doing is, and this is the question that Sarah asked me. She said, wait a second, it's not increasing. And I said, no, it is increasing. Because look, it is getting bigger. It's just at, you remember that graph that I had with Sarah? And I drew this right here. And Sarah says, no, it's not increasing. And I said, no, it is increasing. It's just at the beginning, it was increasing a lot. And over here, it's not as increasing as much. But it's still increasing. Do you remember when I said that? This line right here is still increasing. It's just at the beginning, it's increasing by a lot, and towards the end, it's increasing only by a little bit. Well, that's what I'm saying, is it's increasing at a decreasing rate. It's increasing, it's still increasing from here to here. From here to here, it's still increasing, but it's not increasing as fast. It's actually increasing less and less. But it's still increasing. And then I said, okay, then it's decreasing at an increasing rate. And so what I'm saying here is, over here it's decreasing, right? But it's actually, over here, it's decreasing only a little bit, and then it's decreasing a lot, and even more. So it's decreasing at an increasing rate. Do you guys understand this description that I'm giving you? I'm talking about it. Do you understand now? How would we make an example of this? I love this example. All right, I'll tell you. I will tell you what this example is of. Okay. Can I erase the words part? All right. Let me show you a perfect example of this. Here's the pen. Take the cap of a pen. Put it right here. Watch this. Ready? Did you see it? It was quick. When you take a basketball and you throw it, take a basketball and you throw it, it actually follows exactly this path. It's called a parabola. There's an example. It's actually a relevant example to your lives. Because you see it. In fact, if you take a piece of paper that you're writing on, crumple it up and throw it inside the trash can, the arc that it follows is exactly a parabola. Boom! That blows my mind. Boom, Mr. Dalday, you're so cool. That's where that example is. That's a great example of that. You've seen this shape before in your life. I've now made math relevant to what you're doing. Or at least I've tried. Are we cool? Alright, let's do chapter 6 stuff. So can you guys feel like you guys can do the rest of them? All right, here. I'll do one more for you. How's that? Let's do this one right here. This one looks crazy. Okay. How would you verbally describe this? First of all, is it increasing or decreasing? There's nothing wrong with my phone. Alright, it's decreasing. Now is it decreasing and decreasing less and less and less, or is it decreasing and decreasing more and more and more? Or is it decreasing just at a constant rate? It's decreasing less and less and less. So technically I would write this as decreasing at decreasing rate. Because it's not decreasing more and more and more. That would look like this. It's not decreasing at a constant rate. That would look like this. That would be a straight line. This one is decreasing, but it's decreasing less and less and less as I go on. Can you think of an example of this? I can think of a great example, and you guys can come up with whatever example you want. But here's my example, because this is an actual real-life applicable example. I'll tell you the equation for this graph, and you might not ever see, you might not have ever seen this before, but I can tell it to you right now. It's f of x equals negative, or e to the negative x. Just trust me on that. Don't understand where it comes from, just trust me. I know where this graph comes from because I've calculated it out before. Eventually, you want this thing to kind of horizontal out. You want it to kind of dip out. When airplane pilots come in on a runway, they actually come down like this. And it comes down, and then they decrease the angle at which they're inclined at, and they decrease and decrease and decrease until they stabilize out. And that is actually, you can use calculus to figure out exactly what angle or what shape they need to follow in order to make a smooth landing. Because if they come in straight, right, and then they just land like that, like basically that would kill everybody. Because you just go down, boom, and then just go straight. Technically the plane would be on the ground. It would just kill everybody. So what you want to do is kind of do a gradual descent. That's that shape. So what this graph could be measuring is the height as time goes by. So as time increases, this is the height. So your height is going to decrease by a lot because you're actually coming down towards the runway, but then it's going to still be decreasing, just not as fast. Because as you get closer to the runway, you want to horizontal out, you want to smooth yourself out. Does that make sense? Are we cool with this? I got a phone call coming in too. Alright, 1 second. I'm going to answer the phone. I got to remember to call my wife back. Hello? Hey, what's up? I am. I left the schedule. I'm going to teach until 12, and then I got 2 o'clock to 3 o'clock. If you look at my thing, I actually have the budget to my board. Anyway, what's up? No, isn't. I do, but I only had I have a 5-minute break in between, and my computer was breaking down, so I need to try to get it fixed. Anyway, what's up? Is there something you needed? Yeah, I did. For you to use. It's on there, or at least it should be. It runs in the background sometimes. Okay, I'll make sure that it's on there a little bit later, but I know that it's running on there, or at least it's loaded up on there. So, okay, it was. Okay, I'll take a look when I get home. All right, okay, bye. Sorry, you guys. All right. Whew. Okay. Let's take a look at this one. All right. You ready? Determine which of the function graph matches the statement, indicates why the other graph does not match the statement, state the possible function domain, and range output values as possible. All right. Do you guys remember the word domain and range? Do you remember what we? Okay, we've got 4 minutes left, so I need to go quickly on this because I've got another class to start up on. Do you remember when I talked to you guys about domain and range? Say yes or no. I'm not going to yell at you if you say no. Don't worry about it. Yes. The domain is what is allowed. Remember I told you guys functions are like chicken katsu. And the domain is things that you're allowed to put into that function. You guys remember this story? And I talked to you guys about chicken katsu being this relationship, and I had this store that I opened up called, Chicken Katsu or Us or whatever, and it is it's called Chicken Katsu or Us, and it's what it is you can bring in your meats, and I can make chicken katsu out of it. Now, what I need to do, or what I had a restriction on, is I said, I have a restriction on the domain of this restaurant. You can only bring in raw meats. I'm not going to allow you to bring in a computer speaker because I can't make chicken katsu out of a computer speaker. Do you guys remember this story? And I know, Natasha, that you are brand new to this class, and so I apologize if this doesn't make sense to you, but I hope this makes sense to the rest of you. Tell me yes or no. I need to know what your thoughts are. Because I've got now 3 minutes to finish off class. So I can start the next class at... Yeah. Alright. So the domain is what is allowed in. Now, if there's only a certain amount of things that are allowed in, then there is only a certain things that are allowed out for that example. So let's do the first 2 of these things. All right, you ready? And let me explain to you what the domain and range are. A school bus drives 30 miles per hour for a while and then pulls into the school and lets off its students. All right, which of these graphs, which one of these graphs, do you see them? Matches that description, the first, second, third, or fourth. You want to be driving 30 miles an hour, and then at the after the school bus reaches the school, they're moving at a constant rate. That constant rate, the constant change of their distance is 0 in this case. Which of these graphs match that description? The last one, exactly, part D, because it's moving at a constant rate, and then it's rising at a constant rate, and then over here it's moving at no rate. It has no change. It's a constant all the way across the board. Does that make sense? Now, here's the question: is what is the range? Okay. Well, let's pretend the story ends there. One second. All right. Let's pretend the story ends there. Let's pretend that this thing, the bus goes like this, and then it goes at a constant, it just stays there forever. It breaks down. The bus is broken down. It no longer works. Got it? So for the rest of its life, it's going to stay at the front of that school. If this is the distance and this is the time, how far is this? It drives 30 miles, and then it gets to school and lets off its students and just stays there. How far is this? Come on, you guys. I'm out of time already. I need you to answer. I'll just tell you. It's 30. You're 30 miles away. You guys got it? You drive for 30 miles. You finally reach there. You got to the school. Boom, you let people off. Now, here's my question. Will there ever be a time when the bus is 15 miles away from your house? Here's the school. Here's your house. Will there ever be a time when the bus is only 15 miles? And the answer is, of course there is. Because if you went from here to the school, then there's going to be some time over here where the bus is only 15 miles away. Right? Yeah, exactly. Will there ever be a time when the bus is 10 miles away from your house? Yeah, come on in. Will there ever be a time when the bus is 10 miles away from your house? Yeah, of course, over here. But here's my point, is will there ever be a time when the bus is 40 miles away? The bus goes from your house to your school, and it travels 30 miles, and then it breaks down, lets off other students. Will there ever be a time when this bus ever reaches 40 miles away? No, exactly. And that, my friends, is what the range is. The range is a restriction on what y values are allowed to come out. You can put in any x values. I can put in any time I want. I can wait 100 years. But this bus, in this particular situation, will never get to 40 miles because it's broken down or let off the students and they didn't finish the story for us. So the range for this is between 0 and 30. It is what is allowed to come out of the y values. Does that make sense to you? All right, I'm sorry.
Algebra 1.
This is actually Algebra 1.
Okay.
I have to stop class because I got to start another class in 3 minutes, but I got a parent talking to me, so I'll talk to you guys later. Have a wonderful day.